some dyes, which shows proteins, fats, phospholipids. I will also show the phospholipids in the future slides. And then this shows how the proteins and lipids have been interacted and how it has been disrupted when we are using the Falch extraction and the switchable solvent extraction. So, and this is a determination of the phospholipids. These are the phospholipids, and this graph shows the particle size. So why this particle size is relevant is because to see how we are having the solvent and we are trying to break down the phospholipids. So, and we want to see how it has been disrupted. So we try to do a particle size using a particle size analyzer such as Mastersizer, and we were able to clearly see the reduction in the size of the solvents by for the buttermilk, which was untreated, and then the Falch and the switchable solvent. So this is an untreated buttermilk. This is how a phospholipid looks by using a confocal laser scanning image. This is how a phospholipid is, and then further when you treat with Falch and the switchable solvent, there was a reduction in the size of the particles. So this shows that the solvent can easily percolate into that small holes, and then you can see how it has been disrupted. It was easier for, thereby enhancing the extraction efficiency. It was very easier for the solvent to go in. So a technique which we used is the scanning electron images. So this is a confocal image which shows how the presence of each components like the phospholipids, fats, lipid by staining with different dyes. But then scanning electron microscope overall shows how the cross morphology, how the structural changes in the system. Further, we used HPLC, high pressure. So as I said, like in the beginning, we used the TLC technique, which is a quick technique to measure the individual phospholipids. Similarly, HPLC is a robust technique using charged aerosol as a detector, which shows the concentration of the individual phospholipids. So as we can see, this is a composition of buttermilk and the individual phospholipids which are present, and we were able to see the presence of individual phospholipids clearly outweighed the switchable Falch extraction methods, and the switchable solvents had a higher concentration of phospholipids in all levels. And this is a distribution graph of all these phospholipids. Its form. Further, okay, so as we know, we have started this technique, and the other approach we need to start approaching, like we started with different byproducts like buttermilk, beta serum, concentrated buttermilk, but then beta serum was something which was really of interest in the industries, and we wanted to know because they had plenty of beta serum powder which has similar characteristics of the buttermilk, and they wanted to use it in some way. So we used a new technique involvement of ultrasound pre-treatment. So ultrasound is a novel has been studied extensively for emulsifications, extraction of valuable components like polyphenols, enzymes, so many in agro products. Ultrasound has been used extensively, so we try to adapt this ultrasound technique as a pre-treatment for our research as well. So ultrasound has a high frequency, generates sound waves that creates turbulence through alternate compression and fractions, which helps in breaking down the fat globules. So once it is already broken down, and further using the switchable solvent will help in more enhancing more extraction efficiency. So when we used only the switchable solvent alone, the B serum extracted only like around 7 to 8% of the phospholipids. When we involve the ultrasound pre-treatment, the acoustic intensity which produces the cavitation effect, which help to break down and then So when you break down, it becomes smaller. These smaller particles help from the ultrasound, help along with the switchable solvents, help to increase the extraction yield, help to get the phospholipids quicker, and also more, it enhance the efficiency. So as we can see, we obtain around 70% of the phospholipids, which was 10 times higher compared to the phospholipids without the pre-treatment. Further, the concentration of the individual phospholipids for each switchable solvent ratios were obtained, and we were able to see this particular phosphatidylinositol PI, which was really high, which was 16 times a higher concentration than any other technique. These are also, and further, the focal and scanning electron images also show how the ultrasound. So these are the phospholipids before any treatment, and we can really see how ultrasound has been disrupting these and also helped in enhancing the extraction efficiency and giving a different concentration of the phospholipids. So this also we noted that higher acoustic intensity. We use 3 different acoustic intensities. Higher acoustic intensity yielded a really high amount of phospholipids. Further, these are some research papers from my study, and if you all need for further reference, you can go through these papers. Further, moving into applications. So in the recent times, the term clean label is into existence. So people are looking for more organic, clean label ingredient always. So something which is naturally processed, minimally processed, and also it has to be very transparent. The clean label form, transparent, very simple, not very complex. So for instance, like in dough conditioning, we use acetylcarbonamide, bromate, diacetyl, tartaric acid. Instead of all this, it's replaced by ascorbic acid, which is simple form, natural ingredient. Similarly, like other fibers in recent times, in fiber like inulin fibers, all these are used in frozen desserts and frozen desserts in order to replace as a replacer of stabilizers. A lot of stabilizers is being replaced. So there are also several approaches used in this clean label technique. So such technologies involves ultrasound, high pressure processing, microfluidization, and cavitation. And I will also be discussing a few techniques into which we used in our study to obtain a clean label ingredient. So as I said earlier, this role of lecithin are the phospholipids. So it is these phospholipids are often referred to as soy lecithin because it's obtained from the soy source. If it is obtained from the milk source, we can always use it as a dairy lecithin. That is what our aim, to incorporate a dairy lecithin instead of soy lecithin because of its health benefits various systems. So these lecithins are usually used in chocolates, which helps in reducing the viscosity, helps in expensive ingredients, replaces of expensive ingredients, improves the flow properties, the thickness, consistency, and also helps in shelf life of all products. It's also used in baked goods for as a cooking agent, agent, which helps, and it is also can be used as a fat replacer by itself. So, this can help in giving a better volume for the baked foods, helps in better emulsification of fats. So now, like longer, it helps in longer shelf life, better gluten stability, and increased water absorption in all types of baked goods. Yeah, the other one is the frozen desserts. It is helped in using a replacement of a stabilizer, very creamy texture. Involving these phospholipids gives a very creamy texture by itself. So you don't, which helps in the more melt down properties of an ice cream, like the melting properties of the ice cream is being improved by adding these phospholipids naturally. So, and also in other products like cheese products, instantaneous process. So, as in powders like which can mix instantly with water and get whey protein beverage or a shake. In the instantaneous process, we have a lot of instant powders. So this instant powders go through, once the powder is obtained, it goes through a process called agglomeration. So this agglomeration is a process where which is after the powder which is obtained as a spray dry, and it has been further re-wetted using a lecithin. So in that case, this instead of a soy lecithin, it can be used as a dairy further it is re-wetted to get into like a smaller structure so that it can easily mix with liquids or chocolate shakes. So it can be used in the phospholipids. And further, in other beverage mixes as well. So in very recent times, these phospholipids are of great importance in the infant formula. Companies such as Fonterra, Ala Foods, all these Danish-based companies and New Zealand-based companies are already having their own formula of phospholipids, and they are very much used in the infant formulas because of pain and growth development of the infant has been proved used by consuming these phospholipids. And these phospholipids are also helped in various cardiovascular disease, cholesterol absorption, reduced inflammation. All those things various studies have been proved, helped in neural functions. So in such way, phospholipids are of great importance in these days. So this is a research study from my work where we can see the phospholipids from the buttermilk and the beta serum, the dairy source, and this is the phospholipid which is obtained from the human milk. And studies also say that the presence of phospholipids which is in the human milk are similar to the phospholipids in the dairy source. That makes the dairy source more unique compared to the vegetable source such as the soy and the egg yolk. So these are few studies on phospholipids, milk phospholipids, which are in the recent times reviewed very extensively. So if they are looking for these phospholipids, you can always go into these papers and go through. As I said, this Fonterra, Ala Foods are the companies which are already in existence, which has phospholipids, which they are producing phospholipid concentrate in form of around 20 to 75% of the phospholipids. So another technique which I'll be talking is the hydrodynamic cavitation, which is another clean label technique which can be used as a clean label technique in ice cream, a process of reducing stabilizers in ice cream. So this hydrodynamic cavitation is similar technology, similar principle of producing cavitation effects such as the ultrasound, but producing a stationary cylinder which helps in with a high speed rotating cylinder produces cavitation effects. Due to this high speed, cavities are formed and cyclic growth and collapse of bubbles take place by alternating compressions and rarefactions, and this producing hydrodynamic cavitation. So through this cavitation can be put into work for various mixing purpose, dispersion, reducing the particle size and emulsification. So in our study, we used various ice cream formulations, and we tried to reduce the stabilizers and completely use the hydrodynamic cavitation instead of the homogenization process, which is the typical ice cream manufacturing process, involves mixing, pasteurization, homogenization. But then we try to use, instead of homogenization, we try to use an hydrodynamic cavitator, and also we didn't add stabilizers in the ice cream and just go through the cavitator and try to produce an ice cream without stabilizers. And also we are in the process of evaluating such ice cream formulations by reducing these stabilizers. So these are the small work which we published on ice cream formulations, like hydrodynamic cavitation on ice cream formulations. So another work which I'll be talking on is the utilization of the dairy byproduct beta serum. So as I said, like we are obtaining the beta serum and everything. So it's a dairy byproduct, and it has excellent source of functional and technological properties that benefit the human health. So ice cream, why we decided ice cream? Ice cream is one of the products which is consumed by everyone likes ice cream. And in US alone, the turnover of ice cream, the annual growth reaches by 97 billion by 2023. So we thought of incorporating the dairy byproduct into the ice cream as a replacer for a non-fat dry milk powder. Usually an ice cream consists the non-fat dry milk powder to maintain the total solids. So instead of the non-fat dry milk powder, we are using the byproduct which is obtained from the which is a low value byproduct, and we see how this low value byproduct has helped in the ice cream manufacturing process. So and also we tried, since it has been in the starting level, we tried to see how the presence of phospholipids in every stage of the ice cream manufacturing process, starting from mixing. We saw the presence of phospholipids, and then after pasteurization, then after freezing, all these images were taken using a confocal laser scanning microscopy, using a dye called RD-dope, which is used to stain the phospholipids. And those phospholipids were quantified using Falch method to see, and we were able to see. So this upper phase and the lower phase is something which we centrifuged to see where it lies. Is it the phospholipids in the upper phase or the lower phase? And we were able to see most of the phospholipids in the lower phase, and it also decreased depending on the type, depending on the stages. So this is quality behavior of an ice cream, which is and we saw the melting behavior of an ice cream using a temperature sweep test. So this is a rheological behavior of ice cream is very important in studies, because it all depends on the melting behavior of a frozen dessert, not on ice cream. In any other frozen desserts, the melting behavior is something which is important, and also it is important to see the viscoelastic behavior of the mix. So the hardened ice cream was taken and analyzed for the melting behavior using a rheometer, using an oscillatory analysis using temperature sweep test. So the temperature in the rheometer was obtained from -20 to 10 degrees Celsius. So you can see like the three zones, and so the G dash and the G double dash, the storage modulus G dash and G double dash loss modulus was plotted against the temperature, and it was divided into three zones. So the zone 1, which lies between -10 to -20 to -10 degrees Celsius, which shows the scoopability and rigidity of, which depicts the scoopability and rigidity of the ice cream. And then in this case, there was higher G dash and G double dash values. So the ice cream with B serum had higher rigid structures which contributed to the scoopability and rigidity of the ice cream. So the other zone 2 is involved, which lies between -10 to 0 degrees Celsius. In this, all these you can see how it has been decreasing. All there will be a reduction in both the storage modulus and loss modulus, which shows the impression of coldness dominating icy structure. It is zone 3, which lies between 0 to 10 degrees Celsius, in which all the ice are melted into liquid. And then you can see the dispersed air and fat phase at that point when it comes up to 10 degrees Celsius. So in our case, this ice cream with the byproduct, the beta serum, which is a byproduct, had more dispersed air and fat phase, which had higher creaminess, which also this contributed to the creaminess of the ice cream. Further, I'll be concluding like few properties. So as we all see, like the phospholipid, we saw the phospholipid importance and application in various processing aids. Not only phospholipids, there are other dairy permeates, whey processing, cheese base. All these are all byproducts, and they have been used in various purposes. And the process, the switchable solvents, are new upcoming trend of solvents, which is also used in algae research, soybean processing, which is a very sustainable technique, which shows great potential for overcoming substantial financial and logistic bottlenecks. And since these dairy byproducts, it helps in generating income, and also it helps to utilize more byproducts because the industry generates a lot of dairy byproducts. So this is a way to how effectively we can utilize these byproducts. So as I said, there is also these switchable solvents can be also used to obtain oils from other agro byproducts. And yes, dairy can be a very good clean label solution to meet consumer expectations as a clean label product, as by nature itself. Thank you. So I would also like to acknowledge my PhD supervisor, Dr. Sergio, and also United States Department of Agriculture and National Dairy Council for funding my research program. If you're interested, I can also share a few things on how this switchable solvents, we are researching how this switchable solvent, not only for the dairy byproducts, we tried using it to obtain coffee oils, using the spent coffee ground, which is from our same department where they use the spent coffee ground, and using this switchable solvent, we try to extract the oil. Not only oils, we obtain like different components, oils, phenols, chlorogenic acids, fibers. From a single extraction step, we were able to obtain 3 different byproducts, and further this solvent was again, which can be reused as well for other multiple extraction process. So this is a fractionation of the individual, and then we were able to see, we tried different methods, compared with different methods to see how efficient was it, and we were able to see the switchable solvent gave a higher yield of coffee oils from compared to other methods. So in a way that we can also use this switchable solvent, which is an emerging solvent, green solvent, in not only in dairy but also in other agro products, like oil, to obtain oils in avocado seed oil or something like that. Yeah, this is small work on like understanding the extraction process, overall extraction process, in order to show that how well this there are no residues present during the extraction, and to see how this solvent doesn't come in contact with the food substance. And so this is also a paper which shows the fractionation of the spent coffee ground using this. If you are interested, you can go through this. Thank you. So once again, yeah, I would like to thank everyone for attending my presentation and for giving me this opportunity to present in front of you. Thank you. And if you have any questions, you can write to me to my email ID. Yeah, thank you.
So, thank you, ma'am. Thank you for providing a wonderful knowledge sharing session on the dairy byproducts and its application and its processing and its application. And the students already have studied. The final year students already have they have studied about the dairy processing, dairy engineering course in the previous semester, and it will be giving a. They have studied about the dairy products and dairy processing, but they don't have any idea about the dairy byproducts. And the sessions like it covers the hydrodynamic cavitation and all, and the volatile extraction, those things and all. It's a new thing to them. So it is a very good knowledge sharing session that they have their opportunities with respect to the dairy processing. So many of the speakers have spoken about the entire other processing aspects, but they have not covered about the dairy oriented and all. And even some of them have covered about the image processing and all, but this is the first time they are receiving the knowledge from like a dairy byproducts and the application where we can. So it's provided a very good knowledge for them, ma'am. Thank you, ma'am, for providing such session. And it's time.
Thank you. Thank you for inviting me. Yeah, I'm really glad to be part of this session and share my knowledge in this. Thank you.
Thank you, ma'am. And it's time for students to ask questions. If you have any queries, you can ask through the chat box, as well as you can unmute and you can speak. If you have any queries, you can put in the chat box, or else you can unmute the mic and you can speak. Is there any queries from student side? I think two of them have raised their hands. Sorry, number 20113046. Any student, do you have any queries? I think they might be shy in sharing the questions. I think so.
So yeah,
Um,
I have put my email ID in the chat box. If you have any questions or queries or anything, I would be happy to help with that.
yes, ma'am. Yes, ma'am. The mail ID is posted in your chat box also. So any kind of queries, like even in the like opportunities also, you can ask, ma'am, regarding
Yeah,
the mail.
definitely.
So that
Yeah,
can
yeah.
help you. So the opportunities, if you need it, so that also ma'am can guide you. Even if you are doing a post graduation, or else the after completion of the post graduation, that will be how to apply. So that guidance also you can receive from ma'am. You can share your thoughts also through the mail ID. Okay, if no other questions, Hita Baburaj, we can conclude.
Thank you, ma'am, for sharing your valuable thoughts. It was a great time with you. Now, I call upon Darshana of Final Year Food Technology to deliver the vote of thanks.
Good morning, everyone over here. It is an honor for me to have an opportunity to deliver the vote of thanks on this special event. I extend a hearty vote of thanks to all delegates of this webinar for their presence and contribution to make this session exemplary. I extend my thanks to our Honorable Chief Guest, Dr. Kavya Ratnakumar ma'am, for enlightening us with her knowledge and giving deep insights on dairy byproduct processing and applications. I'm pretty sure the precious knowledge you gave us will help us in our future career. Once again, and thank you, ma'am, for taking out time from your busy schedule. Thank you, ma'am. A special thanks to the management, the CEO and principal of our institution, Dr. Karunakaran sir, who is a sculpture of motivation to us. Thank you, sir. I extend my gratitude to the head of our department, Dr. Srinivasan sir, for always working for our welfare and having encouraged us and guided us in all our ups and downs. Next, I thank all our department faculty members, especially Dr. Jeevarathinam sir, for organizing such an informative session for us. Last but not least, I thank all the students who have shown their presence and involvement throughout the session. I once again thank everyone who made this webinar a fruitful one. Have a nice day.
So thank you, ma'am. We have planned this session in the previous month itself, but due to the time, we are planning, and last 2 days before only we confirmed the session, and today we have.
No, that's fine.
Thank you, ma'am. Thank you for
Yeah,
giving the opportunity to hear the lecture. Thank you, ma'am.
yeah. Thank you. Thank you very much. Yeah.
Students, you can leave the meet now. Thank you.